Hi, everybody. Just before I begin, I want to wish you a happy Thanksgiving. Have a wonderful week, and I'll see you next Monday when we return. Today, I'm going to lead you through an analysis using SPSS. The video is in 3 different parts. The first part is I'm going to show you how to import data from Excel to SPSS. We've done this before in class. The second thing that I'm going to do is I'm going to conduct a correlation analysis with you on the exercise adherence data that I import. The third thing that I'm going to do is run an independent means t-test and then a dependent means t-test. I'll describe these various tests as I come upon them. If you are doing an analysis of variance for your study, in other words, you have 2 independent variables that you're studying, or if you have an independent variable that has 3 or more levels, then we will cover that next week. So I want you to notice that right now I'm in SPSS. And what I'm going to do is pull down the file menu and choose, excuse me, open. And then I'm going to choose data. Once I click on that, it opens up a new dialog box. Notice that I don't find the Excel spreadsheet here. That's because I have to change the file type. It's now looking for an SPSS file. I need a Microsoft Excel file. So I'm going to choose Excel. And you'll notice that now my exercise adherence data set is available to me. So I could then click on that and it will ask me, do I want the data from sheet 1 of the data set? And what rows and columns do I want? And it gives me an example of what that data looked like. So I'm going to choose OK. And you'll notice that everything is here. I'm actually going to close this right now. And I'm going to open up the exercise adherence data set that is already saved as an SPSS file. So I'm waiting for that to open. The difference here is that I've done the dummy coding, or I've done the coding of the values of the various independent variables. You'll notice that right now I'm in the variable view. Also in this data set, I've assigned z-scores to the data, but we're not going to actually use that in this data set, so that's not important. I'll go back and here's my actual data set. Just to come back to those z-scores, those are standardized scores. In other words, what it does is it takes all of the scores and puts them on the same scale. And the scale essentially is a -3 to a +3. So you can see that all of these scores range between a -3 and a +3. Okay, at any rate, here's my data set. It's exactly the one we've been working with. And we are now ready to do SPSS. So now I want you to notice that we're in data view. And you could see our data here. What I want you to notice again is how all of the variables are listed in the columns, and in the rows you find the data. Notice that all of our variables are dummy coded. In other words, even subject ID is dummy coded. It certainly is in the order that they come in, but it's arbitrary in terms of how those codes are assigned. You'll notice sex and its 2-level variable. The same age is a 3-level variable, 0, 1, and 2. Notice that there's somebody who has missing data here. Exercise type is a 2-level variable, 0 and 1. Frequency of exercise, you have a 3 or 4-level variable, 0, 1, 2, actually a 3-level variable. And then exercise adherence 1 and exercise adherence 2 are continuous variables, as we've already identified. So what we're going to do now is run a correlation analysis. Which of these variables would be appropriate to run a correlation analysis? Well, we know that a Pearson correlation can handle 2 continuous variables. The 2 continuous variables that we have in this data set are adherence 1 and adherence 2. So let's go to Analyze, find Correlate, choose Bivariate, and then move adherence 1 and adherence 2 over to the variables box. Notice that Pearson is checked. Also, now notice that two-tailed is checked. In other words, we're going to be testing the null hypothesis here. Also notice that I've asked SPSS to flag the significant correlations. I'm going to go to Options. I'm going to choose Means and Standard Deviations and choose Continue. And then I'm going to choose OK. And sure enough, I get my analysis. So what this shows is that the mean for adherence 1 is 151.08, and the mean for adherence 2 was 157.40. So my assumption is that adherence went up by the second adherence measure. I'm not sure why that would be true, based upon the design of the study, the manipulation that I had, what kind of intervention that I had between adherence 1 and adherence 2. We're not really interested in the means in this analysis, but I just wanted to look at those. Look at how close the standard deviations are to each other. That shows a lot of homogeneity of variance between the two groups, right? At any rate, here's our correlation table. It's the same one that I have in the slide set. If I were able to draw my line here, you would see the same below the line as you see above the line. At any rate, you could see that the correlation between or among adherence 1 and adherence 2 is significant at the O1 level, and that's for a two-tailed test. So we've had a lot of success so far with our analyses. Now we're going to run an independent means t-test. So what is it in our file or in our data set that would be appropriate to run an independent means t-test? In other words, I have a between subject independent variable, and I want to examine the effect of that independent variable on a continuous dependent variable. The rule in a t-test, you'll remember, is that an independent variable only has 2 levels. So in my data set, I have 2 variables. Exercise type is 0 and 1, or aerobic and anaerobic. And sex is 0 and 1. 0 is male and 1 is female. I'm actually going to take each of these separately and analyze adherence 2 as a dependent variable. So I'm going to go to Analyze. This time I'm going to compare means. That's exactly what I want to do, is compare the mean between the exercise type groups. In other words, between the aerobic and the anaerobic group. I'm going to choose the independent samples t-test because each group, the exercise type groups, are independent of each other. And I'm going to make sex my grouping. I'm sorry. I'm going to make exercise type my grouping variable. And you'll notice that when I do that, I get these two question marks here. I need to go to define groups, where group 1 is 0 and group 2 is 1. And now my test variable is going to be adherence 2. Again, I want to go to options. Everything here is exactly as I want it to be. And I'm going to choose OK. Now notice that I get a t-test. That's my analysis. It gives me what the design of the analysis is. In other words, I'm looking at the effect of exercise type, aerobic or anaerobic, on adherence to scores. I had 39 people in the aerobic group and 33 in the anaerobic group. You'll notice that their standard deviations are quite close to one another. Also, in the aerobic group, the mean was 158.62, and in the anaerobic group, it was 155.97. What we want to know is there a difference between these means? Even though we see a difference numerically, we want to test whether that difference is statistically different. So we go down to our independent samples t-test, and what we see is, once again, the analysis of adherence to scores. This time we're going to skip over the F-test and the significance of that, and we're going to look at the t-value, which is 0.652. Notice how high the degrees of freedom are here because we have a large sample. So the degrees of freedom get larger. And what I want you to notice is that this value is not statistically significant. So surprising to us, the statistical difference with 72 subjects in the study between a 155.97 and a 158.62 on the exercise adherence scale was not statistically significant. Let's look at it on the effect of sex on this. So let's go to Analyze, Compare Means. Once more, independent samples t-test because you can't be in both groups. You're only one sex. I'm going to move that over to the, let's go down to exercise type, move that back. Let's choose sex, move it over. Notice again, I have to define my group. 0 and 1 is fine. Okay. Here I see that the means are almost exactly the same for males and females, and of course, that statistical difference is not going to be even close to a 0.05. Realize that this is more than 90% unsure. We want less than 5% unsure or by chance alone. The last test that I wanted to show you was a dependent means t-test, or they may call it a dependent samples t-test. Let's go back to our data set for a moment. Notice that we have a repeated measure. It's repeated time of test. In other words, they had a time of test 1 and a time of test 2. They had the exercise adherence test both times. So let's go to Analyze, and let's choose Compare Means. And this time, actually, it's called a paired samples t-test, paired samples, because it's the same people across both measures for the t-test. And this time, the pair would be adherence 1 and adherence 2. Move that across. And I have options here. Again, everything is just fine. And I'm going to choose OK. And now I'm down here. Notice that in the paired samples t-test, again, this is what we saw earlier in our means when we did the correlation analysis. This difference here, is it significant? When I look at the paired samples t-test, look here, the t-value, that's the value that you get at the end of the t-test, is a negative 10.85 with 71 degrees of freedom. And look at how great that level of significance is. So regardless of sex and regardless of exercise type, the participants improve their adherence over time between test 1 and test 2. So again, I want to wish you a happy Thanksgiving. And as usual, anything in this slide set is very important for us to move forward into our lecture next week. So please make sure to pay attention to all of the terms and attempt to understand how your design for your data fit with the designs that we're looking at in these analyses here. Have a wonderful Thanksgiving, everybody.